All right, guys, we're gonna get started. I hope you guys are doing well. Um, Happy Thanksgiving, and just a quick reminder. Oh, we have students adding. Let me. All right, I'm gonna restart here. Um, so, I just want to wish you guys a very happy Thanksgiving. Next Sunday we don't have class, of course, but the following Sunday is our last class, and that completes the ACT class for the fall. And then December 11th is the ACT test. So could you guys tell me how many of you are taking the December 11th test?
I am.
I am. I might be.
I am.
Reagan, you said you might be.
Yeah, I'm not sure if I am yet.
Okay, because the registration due date was November 19th. Have you signed up?
I'm not sure.
Okay, okay. There is a standby option, but yeah, yeah. I think the deadline was November 19th. So anyway, I'm planning to talk to your mom soon, so let me touch base with you, okay? Anybody else taking the test? Okay. Few things I want to share with you guys is between now and December 11th, if you guys have any questions, make sure you guys ask me the questions. It is very important to ask questions. And I know that some things, some that has gone by the side lately with this class and even the spring class. People did not ask a whole lot of questions. Summer we had a lot more people asking questions and preparing for the test. So if you come across something you do not know, please ask. That's why we are here for, is to answer your questions. So do not hesitate to ask the questions. All right. Do you have anything to ask me? Any questions? Any doubts? Any questions? All right. So today is the last math class. We have one small topic left, and there is a small portion we're going to finish, and then we're going to do a science. And the last class, which is on December 5th, we'll be doing ACT writing. So go and open page number 5 of the math packet. And we're going to do trigonometric graphing and trigonometric functions. So trigonometric graphing. And we do not have to go a whole lot of in detail. So, and I really want you guys to ask questions. This is my priority today. So even if I spend the whole time on this one, I'm fine with it. Science is just an extra at line in case we are done early. So everybody needs to have your graphing calculator. So go ahead and get it, please, if you don't have one. And do thumbs up when you have it. We all need graphing calculator, otherwise it'll be hard to do this. And some people don't have calculator. All right. Now, in the graphing calculator, in the window, I would like you to set up this for x minimum, do negative 360, x max 360, y minimum, let's say negative 5, y max 5. Do the setting in the window. Again, if you need more time, just have to tell me. Otherwise, I'm going to assume that this is good enough and we're going to move. In the y is equal to, in the y1, type in sine x. Type in sine x. In y2, type in 2 sine x. Go ahead and hit the graph button on the top right. All right. Are you guys getting this graph like this? And you guys really need to talk, otherwise it becomes slow today. So you really need to talk to me. I don't mind you. Okay. Now, go to window again. For the X scale, make it, let's say, 45. And again, graph it. I want to show you how to practice this. And then you can do X scale as 90. So you can vary the X and the Y to make it look better. So as you plot the graph, so I'm just going to show this one. So let's call this as 1. Let's call this as 2 here. So for the y is equal to sine x, you get a graph something like this. For y is equal to sine 2x, so this is the y1. For y2, you're going to get the same graph, but this is changing. What we call the amplitude is changing. But these points remain the same. These points remain the same. So these are called the nodal points. They are not changing when the amplitude changes. So this portion, this is called the amplitude, and amplitude is always a positive distance, a positive value, because it measures distance. All right, next. Let's do, we always gonna keep y1 as sine x. That's our base, okay? Now for the y2, instead of 2 sine x, make it as sine 2x. 2 is inside. Sine 2x. So what happened, guys? Again, talking to me really helps. Otherwise, it's like I'm expecting you to be involved in this class. Really, otherwise it becomes hard. So what happened here when we do y is equal to 2 sine 2x?
There was twice as many wavelengths.
So, see now what happened exactly. So let's talk about it. That's called the period. Period is 2 pi over b. We call this as b. The coefficient of x in the parentheses is called b. 2 pi over 2 is pi, and pi is nothing but 180 degrees. So in this case, what happened in the original y1 is equal to sine x? The period was 2 pi over b, but 2 pi, b is 1 here. So that's 2 pi, which is 360 degrees. So here, the one wave was 360 degrees. Now here the one wave is 180 degrees. That's why you have two waves in that 360 degree period, or 180 degree is one period. So remember one thing, when I draw the wave, this is what's called a one full wave, and this defines a one period. Now we're condensing the number of periods when this increases more than 1. So 3, it becomes 2 pi by 3. 4, it becomes 2 pi by 4, and so forth. So when they ask you to find the period of a sine or the cosine function, you are looking for this equation 2 pi over b. Are you guys so far okay with this? And they won't ask too many difficult questions on pre-calc. I just want to make sure that you guys know the basics. Now,
I understand.
what's that?
I said that I understand it.
Okay, how about others?
I understand it. I'm good.
Okay. Now, on the y3 for this one, for y3, do sine 2x, but close the parentheses, then do plus 1. Do plus 1, which is outside of the parentheses. This is called vertical shift. This is called vertical shift, where you actually move the graph up by 1, or you can move it by down, or whatever it is. So if it's outside the parentheses, this is called the vertical shift. So they can ask you the amplitude, they can ask the period, they can ask the vertical shift. And this is exactly the same for sine and cosine. There is no difference in the equations. The period is the same, the vertical shift is the same, the amplitude is the same. So that will never change. Are you guys okay so far? Okay. Now, the fourth one is the toughest one. And I want you to be attentive. And I've not seen a whole lot of questions lately. Maybe once in 3 ACT tests I've seen one question. This is called phase shift. Now remember, when vertical shift, you take the wave up and down. In the phase shift, you take the wave left and right. So what I'm going to do is I'm going to write the equation which is in your book. So in your book, does it say minus C or plus C in the math packet?
It says plus C.
Okay, let's use, it doesn't matter actually, plus or minus. I'll tell you why. Okay, this is what we call a sine wave that includes everything. D is the vertical shift, A is the amplitude, B corresponds to period. Now what does C does? C helps us to find phase shift. Phase shift is equal to C over B. C or B? Okay. Now, they also will ask you whether it's moved to the right or to the left. So what I would like you guys to do in your calculator, and I want everybody to do this, sign x minus 90 as y2, and y1 will be the same one here. And I want everybody to plot this, please. I want everybody to do that. Sine x minus 90. Remember, it's in the parentheses. Okay. You observe the two waves and tell me what has happened between the difference. Come on, guys. If you look at the wave, two waves, what has happened from y1 and y2?
It moved one full unit.
Yeah, to the right or to the left?
Would have been to the right.
To the right by 90 degrees. So now that's why I was talking about why this plus and minus doesn't matter. So when it is minus 90 degrees, so I'm going to talk about this now. When C is negative, the wave moves to the right. When C is positive, it's to the left. Let me explain why it happens like this. So, this is the y1, this is the y2. Let me draw the dotted line so you can see that. Okay, here you go. Now, the dotted line is this one. So why, when it is negative 90, it moves to the right here? Because you have to add 90 degrees, you have to add 90 to go back to the origin here. So you have to do plus 90 to go back to x, that's the origin. So when it is plus 90 degrees, you have to do minus 90 in the opposite direction to get to the origin. That's why when it's negative, it moves to the right. When it's positive, it moves to the left. So, and you can plot that as well for y3. Practice sine x plus 90 and you will see the difference. Everybody try that, please. Now put y3 as sine x plus 90. Did you guys see that? Did you see the difference? Reagan, JC, what do you guys think? Are you guys seeing the difference? Okay. So when I want to give some couple of important points. That's something you need to be careful here. When you do this, okay, everything is in degrees. So when they give any calculations on graphing, I strongly recommend everything should be done in degrees. So remember, pi is 180 degrees. Pi is 180 degrees. So even if they give 2 pi over b, everything you have to start converting to degrees when you put it in the calculator. Do not forget this. So even if they give this in, instead of saying in degrees, let's say they give x minus pi, or pi by 2 in this case, make sure you convert this to degrees. Do everything in degrees so it becomes consistent. So I'm going to strongly recommend to work in degrees. So I'm going to put some caution points here. Work in degrees. So this is the maximum they're going to ask you about trig. Graphing and wave functions is this one. Always remember the y is the domain. Y is the range, and x is the domain. That will never change whether it's a trigonometric graphing or normal xy plane. So if they ask for, you always need to be able to plot the graph and find out the domain and the range if they ask about the domain and range, because it clearly tells you here what is the range and what's the domain. So it clearly tells you that. So graphing really, really helps. So I want everybody to type in this. Take out all y1 and y2. This is practice. And I want to see how you guys type this in. Y is equal to half sine 2x minus pi plus 2. I would like every person type this, graph this, and show it to me, please. Either you can take a picture of that and text me, or you can show it here, but I really want this to be a practice so that I'm confident you have done this correctly. Because I know there's a small chance one thing you guys can make a mistake. And I'm practicing as well. All right, guys, show me. You can text me. Okay, Scott texted me. I want to know the graph too, by the way, Scott. I want to see the graph as well. Yeah, you typed the equation correctly, by the way.
I just sent you the picture of the graph too. It's still sent. There you go.
Okay, yeah, that's correct. You guys got it, everybody? The graph is going to look like this. This is what Scott got. And what I was planning to talk about is the equation, how to type this. So the half here he has typed, you can see here, either you can do the fraction form, or if you just do the just half, it should be in the parentheses because of order of operations. So you got to be careful. And then you can see the pi is 180. So these are the two things you need to be careful about. Does everybody get something like this? Remember, the +2 is the vertical shift, so it has moved up. So Reagan says good, Scott's good. Who else? Kira, Carter, Simon. JC, did you get this?
I think my window is messed up on my calculator. So.
Okay, make sure that's what I want to make sure you practice that because that's exactly what happens though. That window can be a real nuisance, and I can tell you it's happening. This is not my calculator. My battery's died, so I just bought it somebody's, and it's showing something weird completely. Look at this. So, yeah, I just want you guys to know that this can happen. So, I got fixed a little bit now. So, the point I'm trying to make here is you have to know how to graph this without and because majority of the answers can be, you can get it correct just by graphing. This is all an extra information. Now, for tangent, so this and sine and cosine, everything remains same. There's no change between sine and cosine. Equations, everything is same. So I just want you guys to know that. Now, let's go to tangent. There's a couple of things I need to talk about tangent. This is the most important, okay? This is the most important. So let's go to tangent. All right, just go to the normal function, not the graphing function. Just go outside to the plane mode, like this. Just go to the plane mode and type in tan 0, please, everybody. And tell me the answers, what do you guys get? What's tan 0?
0.
Okay, do tan 45.
I got 1.
Good. Tan 90.
I got an error when I did tan 90.
Yes. And that is what we call undefined. It says error in the calculator, it's called undefined. So I want everybody to remember when tangent is at 90 degrees, it actually shows an error, what you call undefined. Now, go to the graphing mode and type in, plot y is equal to tan x. Just y is equal to tan x, please. Go do that, please. You guys got it? So, when you plot y is equal to tan x, you get something like this. Oops. I don't know if you guys get this line or not in your calculator, but this is where 90 degrees is. I should plot it wrong here. Oh, no. Let me focus on this right now. So this is my 90 degrees. This is my 0 degrees. So at tan 0 it was 0. At 45 degrees it is 1. So let's call this as 1. At tan 90 degrees it actually becomes what you call an error or an undefined, because at tan 90 it is what you call a vertical asymptote. Is there any student who has heard this word, vertical asymptote?
I have.
Okay.
I have.
Okay. So remember, even if you have not heard, it's no big deal. So I want to talk a little bit about asymptotes. There can be a horizontal asymptote. There can be a vertical asymptote. An asymptote is a virtual line where a function gets close to it but does not touch it. So imagine this. This graph goes up as it goes towards 90 degrees. It will never touch 90 degrees. It will go very close to 90 degrees. They almost are like parallel lines. It just keeps going on forever. At 90 degrees, it goes forever and ever. So when you do the tan functions, look out for what's called the asymptotes. That's one thing to remember. And there's a second difference in tangent for the equation for period. In sine and cosine x, period is 2 pi over b, but in tangent it is pi over b, where b is again the coefficient of x. You have to know these two things, which of course you don't get to see these questions lately. I've hardly seen lately these questions. But remember that in tangents there can be asymptotes. So can you guys see an asymptote after 90 degree, what angle it comes out to? Somebody tell me.
What was the question?
If at 90 degrees was the first asymptote, after that, what is the next angle you get the asymptote?
Would be 180.
So do in your calculator tan 180, does it show 0 or errors in the normal mode?
It gives you a 0.
So then it's not an asymptote then. Then do tan 270.
That gives you the error again.
Exactly. So if first asymptote is at 90 degrees, after 180 degrees difference, you get the next one, the asymptote. And it goes in the opposite direction. So in the negative direction, it will be negative 90. So negative 90 would be an asymptote. You can check it out, by the way. So this is how the graph is going to look like for a tangent for tan y is equal to tan x. But the key thing to remember is you will have something unique to tangent is called the asymptotes. So how do you know it's an asymptote? When you type in the value, if it shows as an error, that's when you know it's an asymptote at that particular value. That's the easiest way to identify is that angle should produce a error when you put tan of that angle. All right, This is all I wanted to cover. Does this make sense, guys?
Yes, it does.
Yeah.
Again, it's not, this is the basics of trig, but this will be very helpful if you get a question. So I want to repeat this. What is a vertical asymptote or a horizontal asymptote? It's a virtual line that the graph is getting close to it, but it'll never touch it. If it's in vertical direction, it's called a vertical asymptote. If it's in the horizontal direction, it's a horizontal asymptote. The main thing to remember in this is it will never touch that virtual line. It keeps going on forever.
Is there any chance we could see a question that like we would see on the test so I know how it like look?
For tangent?
Yes.
Okay, yeah. Remember this question. I don't know the answer choices though, so, okay. Give one value of x where tangent 3x has an asymptote. I do not know the exact wording of this, but it's pretty close to it. Give one value of x where tangent 3x has an asymptote. Of course, they meant vertical asymptote. Has a vertical asymptote. Remember, I told you guys, when you put an angle, it should come out to an error. So, you can always start with 0, and tan 3 times 0 is 0, tan 0 is 0, we know that. Anybody?
I got 90. 3 times 90.
Yeah, I of course I don't know the answer choices. I think it was between negative 180 and plus positive 180 were the answer choices. But remember here, I'm just going to quickly solve this question. Let's put x is equal to 0 and tell me what is tan 0. Of course we know it is 0, okay? Put x is equal to 15 degrees and tell me what is tan 3 times 15, which is 45, well, which we know is 1. When x is equal to 30 degrees, tan 3 times 30 is 90 degrees, so it is undefined, so or vertical asymptote. So at x 30 degrees, we'll have an asymptote. Or you could have just graphed it, because graphing will show you which angle it is. So you can practice this way. Type in y is equal to tan 3x and you'll easily see what angle it is. Scott, does that make sense?
Yes, that makes a lot of sense.
How about other students? Does this make sense?
Yeah.
And as we are doing this problem, let's do one thing quick here. What is going to be the period of this particular function? The period will be, remember, it's not 2 pi over b, it is only pi over b. So b is the coefficient of x, which is 3, pi over 3, 180 degrees divided by 3 is 60 degrees. So the period here is 60 degrees. That means the wave completes in 60 degrees intervals. So remember, this means one wave, whether it's a sine or cosine or tangent. This always tells me in one wave is completed in how many degrees? 60 degrees. The last topic of this is period versus frequency. what is the difference between this wave and this wave?
Is it 3 to 1?
Well, kind of, right? But what is the major difference you see? The difference you see here is this has more waves, this has less waves, right? So this is more high frequency wave. So what is a high frequency means? It has low period. So remember, this one period is the big one here. This is one period, but this has 1, 2, and almost 2.5 here. So this, when the period increases, frequency decreases. You need to know this for your physics class, by the way. In physics, you're going to study a lot of this. As the period increases, frequency decreases. Other way around is, as the frequency increases, period decreases. So you can see that you have many waves in the same time compared to this one. So it's more cycles per second compared to this one. So frequency means, frequency is always opposite to period. So if you have a high frequency wave, you have a very small period. How many of you listen to radio channels, radio waves, I mean, like,
I do when I'm in my car.
yeah, in the car, right? So in the car, when you listen to radio, do you usually listen to FM or AM?
FM.
FM, right? It's called frequency modulation. FM stands for frequency modulation. So what they do is they play with the frequency so that you can actually listen to it clearly. So FM waves are much more clear, but the AM waves, called amplitude modulation, they can be heard over a larger distance, but they don't have the good quality. So basics of physics here, guys. So there are two types of waves, FM radio and AM radio. Many usually listen to FM because it's much more clear, because they're working with their frequency compared to the amplitude. Amplitude, you can take it to the larger distance, but frequency is a shorter distance but much more clear. So that's how the terms comes up, FM and AM. A little basic chemistry 101 or physics 101. I teach this in college. Why we listen to FM more than AM is because it's much more clear. Okay, so we are looking at the high frequency means low period, and this is all you have to know for this part of I've taught you guys way more than I've seen lately. Okay. Do you have any questions? Well, I was planning to do a science test in case we get time. I don't think so we'll have time to do that, which I kind of usually happens, but I usually come prepared. We have 5 minutes or so let me ask you, is there anything you guys want to talk to me as after this? We are left with one more class, and of course usually don't get time to, but no, anything you want to ask, we can use this time efficiently.
What would you say are some of the key things to do like a couple days before, like leading up to like the test?
In terms of preparation?
Yes.
Okay, let's start. So there are 4 sections: English, math, reading, and science. So today is November 21st, and the test is on December 11th. So you literally have 19 days to go. So 18 days practically. So that's like 2.5 weeks. So if you study 2 hours per day, which is the average, that's 36 hours, which is like many kids, many students of mine are doing that. They're doing 2 hours a day, average. So if you're gonna study 36 hours for ACT, out of that, two times approximately 4 hours, 8 would be practice test, the full practice test. So that is 36 times minus 8. That's 28 hours left after taking the full practice test. And you have to take 2 between now and December 11th, with the last practice test not after December 5th. So December 5th should be your last full practice test. Then, remaining 28 hours, identify which are you weakest at. Is it English? Is it math? Is it reading? Or is it science? What I always tell students is math is always 50% of your study prep because that has the highest curriculum. So out of the 28 hours, 14 hours should be for math, where I would go to the practice section, these books, and do problems, use the math packet, use the class notes. So that is 14 hours. The remaining 14 hours is distributed between English, math, reading, and science. Reading and science is strictly practice. There's nothing you can do about it because it varies from one test to one test. But for English, you have to know the grammar, the rules. So you have to spend time in reviewing the class notes which Ryan has taught you guys. And then when you make a mistake, this is so important. Listen to me very carefully. When you make a mistake, don't say, oh, it's a silly mistake, I just did it. Don't waste time on that one. Really dig in and try to understand why I make that mistake. Many students don't do that. This is where a great student and a good student difference happens. A great student will really hone down on, okay, why did I make this mistake? How can I improve? Knowing the details of that question and the concept around it or for it is the single most thing kids don't do it because they think, oh, it's another mistake. And I can tell you, if you're going for pre-med and going to medical school, there is an MCAT exam, and I teach MCAT students, and I spend so much time on this, I talk about how important it is for them to know why they made a mistake. Every answer choice should be scrutinized when you make a mistake. Scott, does that make sense?
Yes, that does.
That's how I would prepare. If I have 20, I would do the minimum of 36 hours between now and December 10th with 2 full practice tests. Anything less than that is you're not prepared enough. I can tell you a small incident that happened. One of my former previous students, semester student, he took the October test. Looks like he didn't do well, and before even the scores came, the dad called and kind of complained that Manoj, we spent all this money and time. My son thought this, he didn't do well, and all those things. I asked him one question: how much time did he study for this October test? He said around 10 hours. I was appalled that somebody would put in 10 hours and they expect a great score. So I'm going to tell you guys point blank here that if you guys don't put in the effort, you're not going to do well. You just won't. This is so much information we have covered. This is the highest we have taught ever. Like last summer, we couldn't even get to this because this is kind of an optional. But this time we have covered everything I'd hoped for. But if you don't go home and study, I wanted to ask this parent who told me this. Scott, you play sports, right, Scott?
Yes, I do.
What do you play? What's your sport?
What?
What do you play? What is your sport?
Baseball.
Okay, so let's say you have a tournament in, let's say, in July of 2022, and imagine you start working for it 2 weeks before. Would you do well in that tournament?
Probably not.
You won't, period, right? Because you don't have the muscle memory, you have not practiced for it. You're going to suck at it. But if you do it from start today, let's say you start working out, you do practice, you do drills, most likely you're going to do well in July because you put in the time, you put in the effort. Is that fair to say that 2 weeks is too less? Reagan, what do you think?
Sorry, I didn't hear your question.
Do you think just 10 to 15 hours last 2 weeks preparation enough to be prepared for the test?
I'm not sure. Probably not.
Carter, what do you think?
No, I don't think so.
Have you taken the test before, Carter?
Yeah.
How many hours did you study?
Like weekly or what?
Yeah, let's go weekly.
I'd say I probably put in like 3 hours every day.
So that's 3 times 7 is 21. So let's go with 20. Let's go with 18. So even if you do 2 weeks in a row, that's 36 hours.
Yeah.
That's simple math. Like I had a student, she scored a 35 in ACT as a freshman. She finished her Duke this year, and I remember her, she was one of my earlier students. I taught her one-on-one. So she did. She took the ACT in the April second week, Saturday. So she started preparing in Feb and March. She spent 2 months preparing, and every day she spent 2 hours studying for ACT as a freshman. Every day 2 hours. That was because she was with me. I know, I've seen her. I've taught her myself. She scored a 35. So she put in 30 times 2, 60 hours. Yeah, she was done. She was done with the ACT in 9th grade, spring. I'm not saying that everybody who puts in 60 hours will get a 35 either, but that's bare minimum is to put in 30, 40 hours of work. And 2 full practice tests is an absolute minimum. Do you have any questions for me? Does this help?
Yeah, I think so.
I feel like it does.
Okay. Again, that's why you have to ask. I have so much experience doing this, so much examples I can share. I can go on forever. One of our students who got a 36, perfect 36, Liz, she has taken 8 full practice tests. She took 8 full practice tests. People who put in the effort usually do well. Have a safe and happy Thanksgiving. And Ryan will be here. And I'll see you guys on December 5th, which is the last class. Start preparing. Bye.